Hello, everyone, and welcome to another DevSecCon London event. So today what we have with us is Jake Hall, and he's going to be talking to us about how GitHub causes you a security headache. Jake is an engineering practice lead at Accenture, and he will be here to talk to you in just a moment. Now, before we kick off, I would love to quickly mention that if you have any questions for Jake today during the presentation, feel free to ask them through the stream that you're on, or head to Slack, and we will get all the questions to Jake right at the end of the entire session. So without further ado, what I'm going to do is I'm going to bring Jake up on screen. Jake, how's it going?
Hey everyone, I'm good, thank you. How are you doing?
Doing very well, thank you. So you're going to be talking to us about GitHub and how it can be a pain, especially when you use it at scale.
Yeah, that's exactly right.
Oh, well, that sounds awesome. We've got a lot of interest because GitHub is obviously GitHub. So please do share how we can make sure that we don't break anything. So without further ado, I'm going to bring you up on screen and you can take the show away.
Perfect, lovely. Well, it's lovely to say hi to everyone today. So yeah, I'm going to be talking about how GitHub causes you a security headache. But before we get into that, who am I? So as mentioned, I'm an engineering practice lead at InfinityWorks. We're part of Accenture. I've worked in all sorts of different sectors, fintech, loyalty, insurance over the years, with a focus on DevOps and agile methodologies within those spaces and transforming those businesses in order to help deliver software faster, more secure, reliably, but ultimately getting change to customers faster so they can benefit from that. Fundamentally underlying all of that is obviously a security piece as well. I have a keen interest in security. By no means am I an expert. I just have an interest in it. And I've ended up being the security champion on quite a number of different projects that I've been on in order to drive forward that security agenda in order to improve those pieces. So what's on for lunch today? Hopefully you're sat down with something nice to eat. You maybe got a salad or a sandwich or something. But in terms of this session, what I'm going to talk to you about today is talking about secure software supply chains, why they're important, and what things to think about around them. Some controls within GitHub that can help you with that. Now, this applies not just to GitHub, but to a wide range of different code hosting providers. But this talk will be very much heavily leveraged on GitHub, given it's the most popular. And finally, I'll be going through a live demo of how we can then automate some of those controls. As you'll see in the demo, it tends to become quite complicated quite quickly, and there's lots of different things to think about and lots of different things to review across a wide estate. But before we get dived in, before we sort of get into the detail of security and supply chains and all that kind of stuff, let's just have a step back and have a look at some of the numbers. So I pulled together a couple of different sources here, which will be shared with you in the post after the session. But 61 million new repos are created each year in GitHub. That's a fantastic number. 98% of code bases surveyed contains some open source in there or what have you. So I think we can say that open source has won, and we're really driving forward that open source agenda, which is amazing. It allows us to move really quickly and allows us to do really cool things with much smaller teams. Another stat of those surveyed repos tells us that 203 dependencies on average per repo. Which is obviously a huge number of different things that we're bringing in from third parties that we don't have to write ourselves, which is great. However, on the flip side of that, 84% of those surveyed repos contained at least one vulnerability. Now, this could be anywhere on the stream of low risk up to critical, actual problem that we need to solve immediately. And the average actually being 158 vulnerabilities across a wide range of repositories. So really, there's quite a lot of risk that we're carrying there in terms of our repositories, our code sources, and things that we need to start thinking about. And finally, we've got proven that supply chain attacks have happened. They're demonstratable. They're out in the wild. In 2018, there was the event stream NPM package that was changed. There was a malicious package that was, there was a package that was added that was then hijacked maliciously, added some Bitcoin and crypto mining kind of thing to it, which meant that event stream, which is one of the hugely popular packages used all over the place, was then distributing this sort of crypto jacking piece of software all over the place. There's another link there in terms of if you want to go and read through that issue on EventStream just to see what happened and how it unfolded. It's a really interesting read in terms of how the developer found out and then went through and told the community. So I definitely recommend having a look at that. Again, those links will be shared after the session as well, so don't feel the need to type those in manually. But hang on a minute, Jake, you've mentioned supply chain, but you haven't told us what it is yet. I'm not sure what it is. So what is a supply chain? Well, fundamentally, it's getting anything along the journey. It's anything along our journey in order to get running code into production. So what I've done is put a quick diagram here that's quite abstract. I'm going to put some tooling to it in a second just to make it a little bit more obvious as to what's going on. But fundamentally, each of these different parts in this diagram has a particular attack vector and something we need to think about in terms of vulnerability or weakness that we need to address in terms of securing our entire supply chain end to end to know that what we've got deployed in production is safe, secure, reliable, and is what we want to be running in production. So starting on the very left-hand side, we've got our third-party dependencies. So again, we're talking about open source software. The average has got 200 and odd dependencies in it. I've worked on software projects where there's been 3,300 dependencies across the whole estate. So that's obviously a huge number of dependencies to keep an eye on and see what's going on. Our build tool is then another potential place for weakness, but that's going to then download some of those third-party dependencies, usually off the internet, to find that that extra open source libraries or what have you we're adding into our ecosystem. That build tool then potentially needs to access some secrets if we've got some internal dependencies or internal systems that we need to be able to communicate with whilst we're doing that build. So there potentially could be some issues there around secret management and what have you we need to think about. We're then producing an artifact with that build tool, which could have baked in issues related to if the code we're writing is vulnerable or has weaknesses in it. If we're writing an authentication chain and our crypto is not great, so don't roll your own crypto. But I've seen issues in production where we're using JWT's JSON Web Tokens that don't have an algorithm specified, so none works. So any JWT works as long as you provide the valid JWT, which is obviously not great from an authentication perspective. We've then got to deploy that artifact. So we've probably got a deployment tool in there somewhere as well if we're thinking about this definitely from a DevOps perspective. We've got our CI/CD going on here. We've split it up in this perspective. Our deployment and build tool could be something like GitHub Actions. It could be something like Circle CI or Jenkins, depending on what your personal preference is. Our code repos here could be something like GitHub or Bamboo or GitLab. Again, GitLab could be our build tool as well. We could be publishing our artifacts all anywhere. We could be putting them in an S3 bucket. We could be putting them into a repository somewhere like a Nexus or an Artifactory. But fundamentally, we've got our artifacts there that could have some baked-in issues, either based on some vulnerabilities of third-party dependencies, or could have some issues based on our own code that we've written. And then we've got to deploy that. We need to make sure that when we're deploying that, we deploy verified and non-vulnerable code. And how do we make sure we do that? And then finally, we're deploying it somewhere that could also have vulnerabilities too, in terms of running it on an EC2 instance in AWS. The underlying operating system in EC2 could also have some underlying vulnerabilities. One of the things I want to touch on as well is in our code repo there, it's quite often assumed that the code that's in the code repo is trusted, but there's actually a huge number of vectors that could mean that our code isn't trusted within that repo as well. There's a number of controls that we can put in place in order to make that better. But obviously, it's a huge number of things I've just touched upon, across our whole pipeline there in terms of the supply chain, and that's just scratching the surface. But before you freak out and worry too much, let's just look at some couple of different risk areas to focus on. And these key areas can really do a huge amount in terms of driving forward that security perimeter and that defense in depth that we need in order to make our code and deployment and therefore supply chain really secure and up to modern standards. One of the first things, I've touched on this a couple of times, is around third-party dependencies. So we've got our dependencies and we need to know what they are. So we could build a graph of our dependencies, get some alerts on it when there are some issues, if something becomes vulnerable or whether a new version has been released. We can use a CVE database for that with CVSS scores, and that's all around the community providing the sort of release information in terms of security vulnerabilities for those different dependencies. So they're telling the community, this version is vulnerable, please upgrade to this version that's now patched. We could also look at automatic security updates. So there's lots of different tools out there, and I'll demonstrate at a very, very high level. One of them we can enable within GitHub, but obviously Snyk does this too, where we could enable ourselves to update for our different dependencies when there's a security patch available, and it will just roll that out for us when we approve it. One of the ways this supports us is that it means that we are reducing the number of vulnerabilities that are known in our code that are in production. We've got visibility on how much risk we're carrying, but also we're reducing the sort of critical and high level risk in terms of those scores in order to be able to drive that down and be able to push those changes to production really, really quickly, which is actually really important to reducing that attack vector space. The faster we can move, the less amount of time it's vulnerable, the less attack time attackers actually have to be able to take advantage of that. One of the other key things we can do is make sure we trust the code in our repository. So the bad actors here could be somebody within our own organization who's trying to make a change to our systems. Maybe it's the authentication stack and wants to log out all the passwords so they can log in as a different user, maybe to steal credentials, use them in different systems, or if it's an application that's related to money or something secure, like details, personal details, or what have you, steal that information off that person, that personal information, or that actual finance. So one of the ways we can do that is by adding different layers to our defense in depth strategy. The first one is around two-factor authentication. We talk about this all the time in the security space. It's actually really important, not just having something which is your password, but having something you have, like your phone, where you have to present, that 6-digit code. This can be annoying, but it actually massively really improves your security posture just from the get-go, just by effectively adding that from straight away. One of the other things we can do is GPG signing of our code base and all of our commits that go into that. This means that we know who signed a commit and who pushed a commit. Makes it really difficult for attackers who are trying to add code to our repository, maliciously, from being able to do that, because they will need to be able to sign the code as another person, and signing is very difficult if your private key is on your local machine, you've got it password protected. It's very difficult to exfiltrate that private key, get it onto another machine, and then attack that way. It's just, again, another layer. You can't get into GitHub in the first place. Even if you do get into GitHub, you can't commit as that person. You won't get your commits verified. Another layer on top of that we can add is around branch protection. So branch protection is where we prevent any code change with a multitude of different controls, but prevents branches from being changed if they don't meet a specific criteria. One of the common criteria is around peer reviewing, or pull requests in GitHub, as it's called. So what you would expect to do is you'd raise a pull request, get someone else to review it who's trusted, and they would approve it if it looks good, and then that would allow it to then go onto the main branch. That is a really crucial way of being able to manage your risk in terms of who's committing to what repositories, what are they committing, and does it make sense? Not only from a usability, code readability, but also does it fix the problem you're trying to fix or implement the feature you're trying to fix? But from a security perspective, it adds a huge amount of value from that security posture, just because everybody's checking everybody else, and it needs at least now 2 people to be in on the scheme of bad actor perspective in order to get that malicious code into production. One of the final things in our defense in depth cake, so we've got our 4 tiers, is around access controls. So it's all well and good having the 3 enabled above, but if we don't then control access to repositories and our organizations in terms of our GitHub and our code and where it lives, people could switch these controls on and off as they please and use that as a way around being able to do what they want to do. So they could switch these things off if they have admin access, turn off branch protection, turn off GPG signing, get the code in that they want to get in, turn it all back on again. It all looks normal, but actually they've managed to put some malicious code into production that may be doing something that we don't want them to do. Okay, so enough talking about slides. Let's dive over to a live demo to actually show you how this actually would work in practice. I'll talk through some different screens in GitHub as to how they will work. And through that, hopefully, I'll demonstrate, why this is quite challenging to do and why it's also quite tricky to be able to sort of drive that forwards. Okay, so what I've got here is I've got a security demo test organization set up, and all this is done is I've set up this test organization in GitHub. I'm on the team tier, so I've just paid the sort of the minimum amount just to get unlocked a bunch of different features to be able to show this demo to you. But anybody who's paying any amount for GitHub will get access to all the features I'm about to show you. I think it's $4 a month, the plan that I'm on. What I've done also is set up and then a couple of different repos as well to demonstrate how you can then start to have that kind of security and config drift as well in terms of in a big organization. So in some of the organizations I've worked, we've had 300, 500 repositories that are all contributing towards a single product. And it starts to get really complicated really quickly, as we'll start to see. So let me just grab my notes and then I know what I'm talking about. And let's dive into some of these settings. So what we're going to do at the start of the demo is I'm just going to go through some of the settings of how they work in GitHub if you're not familiar with it before. And you can ride along if you want to have a look at your own GitHub settings. I wouldn't recommend you change anything right now because you might break something, but just to take something away in terms of actionable things to change. So let's just dive into our settings. So I'm an organizational admin and I can make whatever changes I want. So one of the first things I've talked about on that list, sort of our checklists to go through, is around two-factor authentication. We can see here that GitHub allows us to require two-factor authentication for everybody within our organization. It's worth saying that if you check this and press save, it will boot out, it will kick everybody out of the organization who doesn't have two-factor enabled. How do you check that? If you jump back to the organization, click on people, you can then see here 2FA tick. So I'm following my own guidance. Excellent. But if I now go back and check that box, it's here. Anybody who knows to try to join my organization, who I give an invite to, will be unable to if they don't have two-factor enabled. I don't know why that's not sticking. There we go. So that means that I now know that I've got at least, you must be this high in order to join my organization, which is excellent. One of the other things I want to point out, I can't do this on the plan I'm on. You need to be on the enterprise plan. But one of the other things is when you're in some certain organizations, having public repos is actually another different security risk. And you can accidentally create a public repo without realizing. It's pretty clear, but when people are in a rush creating repositories, it can be quite useful to come in here and untick this public box. So you're mitigating accidentally publishing any public code by mistake. So you're going back to a default internal only model of private repositories where everybody can contribute in that kind of intra-source model where internal to your organization, everybody can access your code. And that's controlled by this permission at the top where everybody who's a member of the org can control, can read from every repository, sorry. So that's the organization level controls. There's a huge number of other things in here as well you might want to think about, like do we want to allow public page creation? Again, another way to potentially leak information outside the organization without thinking about it by accident, changing org visibility permissions, all that kind of stuff. But we haven't got time for that today. So let's jump back to our repo view. We've got 3 repos here, but if you imagine that in our fantasy land, we've got 200 repos, all set up by different people at different times based on different needs to create a microservice or a different tool or configuration set in order to be able to deploy that product to production. You can quickly see how this will balloon quite, in a poly repo setting. In a mono repo setting, none of these pieces of advice really apply. They apply to the one repo, but you can set and forget. Really, it's a lot easier. In a poly repo setting where you have lots of repos for every different piece that you're running, it becomes quite complicated. So let's dive into our test repo 1, which I set up a couple of days ago. And one of the first things you might have noticed in your own repos before is this security tab. Don't know if you've ever clicked on it, but it's worth having a look. And it gives you this traffic light system in terms of being able to actually dig into the detail of what's going on. One of the things that I would highly recommend having a look into is Dependabot. Just from the get-go, this is part of your cost of being in the team plan. And that's one of the things we talked around in terms of being able to build that dependency graph, understand where your dependencies are, where the vulnerabilities are. You can then get alerts from it. So that's the first one. You can get alerts from it in terms of if there's new vulnerabilities that affect us, we will then get told about it in GitHub, which is great. And then the third one is around getting it fixed automatically. So they'll raise a pull request on our repository, and we can then merge that in, approve it and merge it if we think it's appropriate. Spoiler alert, it's nearly always appropriate. It's just whether it fits in terms of compatibility. So we can enable these one by one, and you'll start to see it starts to get really tedious if you're doing this over 200 repos. I've just had to click a bunch of times, but we'll get to how we solve that problem in a minute. One of the other things is around branches. So we talked about branch access. So we can see here, this particular repository in this demo doesn't have any branch protection rules, which means that anybody with write access to this repo can just put any code they want on the main branch. And with our CI/CD pipeline, it goes straight out to production. So it means that there are no checks and balances here in terms of getting code thrown all the way to production. We need to just double check about that. So let's have a look at what a branch protection might look like. So if you've never set this up before, one of the ways you do it is you can match your branch against a pattern. So if you want to protect all of your feature branches, you could do something like this. So all of your feature branches get managed in this particular way, and then there's a whole bunch of settings that we can have a look through. But for now, I'm just going to use main as my branch pattern. Main is the new default name for branches within GitHub. So it's just one thing to think about. It does tell you on the previous page what your default branch is. One of the things we're going to do is we're going to check the first box, which is around requiring a pull request before we merge something. So that will automatically check that we require an approval. So it means that anybody who's raising a pull request will then be required to have it checked by somebody else in our organization who also has write access, and then we can then merge that change into our main branch. Then it can go to production. So we've had at least 2 sets of eyes on any given change, which is really, really helpful. There's obviously then a whole bunch of other settings in here around who can dismiss things, who can bypass this, status checks, which we can come back to later. Status checks are around if you've got a build tool or you're checking something in your code, you can require that as part of the pull request. So you know you're not adding code that's broken into your main branch. One of the other interesting things down here is around require signed commits. So when I was talking about that GPG signing of commits earlier, this is the part I was talking about. So requiring signed commits is around you have a private key, public private key locally, you give GitHub your public key, then you sign all of your commits against your private key. But then when you push your commit up, not only does it sign all of the previous commits in terms of it knows that it was that commit in that history, but it also will verify that it is you because you've linked yourself to that private key. That means that you'll then get a green verified, which always looks very pleasing in the GitHub UI. And you can then drive forward that understanding that everybody will use those signed commits. And it makes it very difficult for a bad actor to then infiltrate your organization and push code into your repositories if you're requiring signed commits and you're also requiring pull requests. It becomes very obvious very quickly when something's going wrong. So let's create that. So I've just clicked again another like 5 or 6 times. I've had to think about it. I've gone through this. And if I want to roll this out to 200 repos, you can start to see this starts to get pretty tedious pretty quickly. But I've not finished yet. There are more controls that we need to think about in terms of each individual repo. One of the other ones we talked around was access controls. So in terms of access controls, this is the screen where you would manage that. In each repo has different access controls. There is another different screen where you can do it from the team view. So if you have a team you want to add a load of repos to, but you still have to go through and click every repo one by one. So either way, it's really slow to do. I'm not aware of any other way of automating this, apart from the one I'm going to show you in a minute. And you can see here that I've got a engineers team, which has got write access. That's what it's supposed to have. And we can actually see they've got admin access to this repo. So whoever created this repo initially was in a rush or wasn't sure what the permissioning model we have set up is. So they just banged admin on there. Everyone works. Everyone can get on with what they need to do. The issue here is any engineer in our organization now can change any of the settings I just showed you, can remove GPG signing, can remove the branch protection, and can force code into the main branch without any checks, without any status checks, without any signing checks, without any other eyes on it, which obviously is a problem. At least in my scenario, it might be in your organization that's acceptable, but from a security posture perspective, we're trying to limit that risk as much as possible. Now, there actually is a team missing here, and our tech leads don't have admin access. So one of the things we've agreed is that our tech leads can have admin access. So just quickly run through the UI there, add team, search for the tech leads, picks their admin, and then I can add them to this team. So what's that? Typing, clicking, lots of different interactions. Now they're admin, and now I can change this to write access. So this repo now is set up from a security perspective in the right way. But the number of settings don't stop there. You can see there's many things down the left-hand side here. There's 10 or 15 things. There's a number of other different features that are enabled within GitHub. So we've got things like wikis and issues. Maybe you're using a different tool for that. You know, you're a Jira Confluence user, or you're using something completely different for your issue tracking and wiki piece. Maybe you want to disable those so people don't get distracted, and it removes a couple of tabs from the top here, so it keeps a nice clean view. And then there's also the merge discussion as well to have within your team around how exactly do we want to allow merges into our repos. On teams that I'm on, normally we come to the conclusion that we want to be doing squash merges. So let me just tick those. So we've now got our settings all set up how we want them to be. I also like to automatically delete head branches as well. So when you merge your PR, it'll delete that branch. It'll go away, so you don't have to keep going through pruning your branches every so often. But these aren't security related features. These are very much sort of housekeeping kind of things. But I think it's worth mentioning there are lots of features in here that need that manual interaction on top of it. So I've talked again and again around, we've got to keep clicking over and over again about lots of different things in terms of how we interact with this GitHub UI. And it's pretty tedious. Now, if we've got hundreds and hundreds of repos, let me just dive into test repo 2 and just have a quick look at the access controls here. We can see that this one's set up incorrectly as well, that we've got engineers that should have write access only having read, and tech leads having admin access when they're supposed to have admin, they've only got write access. So this repo is set up incorrectly. It requires somebody to go in and fix it in order for people to do their jobs. Maybe it's deliberate, but it's more likely to be an accident. And that's on top of all of the other things that are set up incorrectly. Now, on one of the teams that I used to work on, we used to be able to get code from a new repo into production in about 2 to 3 hours. We had a really slick way of being able to template things and get things out really quickly, but we always came back to the repo settings were always not quite right. So one of the ways that we resolved this is we built a tool and we open sourced it. Now, I don't recommend you use this. The code isn't great. It's not tested. There is no test in it, and it's pretty old. But I wanted to highlight just the concept of what you could do. So the config as code, infra as code, platform as code, all that kind of good stuff. The as code bit, I think, is really important from a DevOps perspective. Those methodologies and those things, in terms of our culture that we hold dear, are really important to think about in terms of how do we solve this problem with automation. So what we did is we built this tool in order to be able to manage all organizational repos, automate it, and align all of the settings across our entire organization. It's designed to be run as administrator on your organization. I don't recommend you do this at all. Just have a think about what you want to do and implement something. It's pretty straightforward. And it does a bunch of different things in order to drive this forward. The link to this repo will be in the notes afterwards, so don't worry about trying to write it down. But fundamentally, what I'm going to do is I'm going to show a quick demo of this about how this, config as code, GitHub as code concept could be applied to your organization and this one that I've set up here. So one of the things we're going to do is we're going to do this check teams piece. I've removed a bunch of these features for this demo, but it will allow us to get a consistent set of permissions across all of our repos instead of having to go through and do it manually, imagining 200, 300, 500 repos. It's going to check our settings for us and go and apply those where appropriate and make them correct. It's going to check our branch protection. So it's going to apply it to the main branch in this case for all of our repos, add some specific status checks we can have a look at, make sure that our PRs are required. And then finally, it's going to enforce GPG signed commits. So let's dive over to the demo. Hopefully, this is readable, and I'm just going to go run main.go. All this is doing is logging in using my GitHub personal access token, which is obviously I'm not going to show you here. It's my personal GitHub account. And it's just going to run through all the repos in this organization. I've got some config set up for one by one and manage each of these repos for me. So let's have a look at what it's saying here. So it's processing our first repo, and it's updating the branch protection because we didn't quite do it right. Actually, even doing it manually, we still missed a step, which is the problem, right? If we do these things manually across hundreds of repos, we're still going to get it wrong, and people are adding new repos all the time. But it looks like the access permissions I did get right, so I should get a gold star for that. The second repo, there was a whole bunch of problems with this. So one of the issues was it couldn't find the team with write access, so it's added that for us. Admin access couldn't find that, so it's done that. The repo settings were incorrect, so it's updated those for us. And the branch protection wasn't there on repo 2 either, so it's sorted that. And finally, that signing protection was disabled, so it's also added that. All pretty much the same problems with repo 3. So it's gone through and updated all of those settings for us. But you can imagine if we've got hundreds of repos, this can run every day automatically, in a GitHub action, scheduled action, and just automatically just check our repository settings every single day. But let's dive over to one of our repos again. Let's look at repo 3. To see that our settings are correct. So first of all, our options, wikis and issues are disabled, excellent, and squash merging is our choice. We then got our access controls. We can now see that engineer write access is correct and admin access is correct. Excellent. That's another load off the mind. One of the other pieces is around, we'll come back to this. This is an organizational level control we can change. Around dependent and dependency graphs. So I'll jump back to that in a sec. And then finally, branches. You can see that we've got our main branch protection rule here. It's got required approvals, and actually it's now got required signed commits. But it's also added for us a required status check. I referred to these earlier, and we can see here the required status check is called build and test. So we might feasibly have a continuous integration pipeline. Maybe it's a GitHub action, maybe it's Circle CI or Jenkins or your personal flavor of build and deployment tool, that we want to make sure that on our pull requests that it works as expected. So a way we can do that is to have this status check made mandatory here, and all of that will be then enforced at that pull request level. So it will then look for that name, and it will then require that as part of our PR. Cool. Okay, so we're nearly at the end of the demo, and I'll jump back in a sec. But one of the things that I wanted to look at as well is the organizational level control for Dependabot, which is security analysis. So you can see here, this one actually has a automated solution to it, which is amazing. I can click enable all on Dependabot security updates. Boom, it's been enabled on everything for us. I can do it on these as well, just to be doubly sure. But if you enable the last one, it enables it on all the upper 3 because it's a requirement. And that's it. All of our repos have now got that enabled. So if I jump to test repo 1, we can now see that in security analysis, they're all enabled. We're good to go. So hopefully what I've shown you now is how to automate some of this. There's an example here, which I would recommend you don't use in terms of being able to run some of this code. It's literally just a GitHub Golang library, again, leveraging the power of open source. Google have written a library for GitHub in Go that I've used, and then basically all I've done is configure this as I need for my purpose for this demo, and then run it through from this perspective. So give it a try and see how it works. Put a pull request up if you'd like to improve it, but I would strongly recommend you go and implement something yourself to give that a go. All right, so let's jump back to the slides, and we're in the home stretch. So that's our live demo. Excellent. So to summarize, please go and check your GitHub security settings. If you have any kind of admin access in any of your repos, please just go and double check them. You can watch this again, it's recorded, so have a look through, and you can skip to the interesting parts and the slides and some of the settings in the demo part, but please go and have a look at them. Each of the different ones are really important for different reasons. So that organizational level two-factor authentication piece means that everybody within our org has two-factor authentication enabled. We know we've got that baseline in terms of everybody is providing something they both have, but also they know the password and maybe phone or security key. So it means that it's that bit harder for an attacker to breach into our organization and start meddling with our code. That branch protection piece is also really important as well in terms of being able to drive forward that control in terms of anybody already in the organization. How do we make sure that the code they're putting into our repos is trusted? We know that we can rely on it, and there's no malicious stuff going in there. There's a whole other host of benefits that aren't related to security around knowledge sharing, around sharing that information with each other, being able to look at that code and analyze it. You are not your code. Being able to have a look deeply into that in terms of, does it actually implement the feature that it was supposed to, or the bug fix it was supposed to, code readability checking, all of that kind of cool stuff that comes with doing pull requests and working as a team towards a common goal. The GPG piece, excuse me, the GPG piece around signing your code means that if someone does manage to get into your organization, even though you've got two-factor enabled, means that we know who pushed code into our repository, and also it makes it very difficult for them to push code and get it into the main branch without actually having a private key set up and all of that kind of other rigmarole that I have to go on. So again, it just raises that bar again. One of the things to do is to review those repo access controls. So we had a look at some of those in the repos today around admin access, who's got admin access, who's got right access to these repos, is it correct across the board? Have we got proportionate admin access? Do tech leads really need admin access to those repos, or can it be more centralized? Or does it really make sense for tech leads to have admin access so they can move a lot faster? And there's always a balance there. We're always talking about security as being a balance between usability and control. And that's where it's for you as individuals in your organizations to work out in your own teams where that balance is. One of the things I do want to call out is when you create a repository as a non-organizational admin, you automatically get admin access as an individual on that repo. So if you've got folks creating repositories all over your organization, which hopefully they are in order to move quickly, if you've got a poly repo set up, there's a chance that different folks have got admin access to all sorts of different random repos. So it's worth just doing a quick review just to make sure that the access is correct and proportionate, and they still need that admin access. The chances are they've got admin access and the engineers have got write access, but they haven't set up any other kind of stuff around it. And then finally, I think this is the main point of the session, is please automate it. Don't try and go through and manually click all the things that I just clicked. I did that pain so you don't have to. There's an example there. Again, don't use that. Just use it as an example, as a way of being able to follow through on the DevOps culture and methodologies of automation first. Then we know we've got a baseline of security across the board, being able to drive that forwards. And we know then we've got at least this level of security on all our 300 repositories. We can then change that code to even keep improving that time over time, and it'll automatically roll out those changes for us. I'm Jake Hall. Thank you very much. If there's any questions, I'll happily answer.
Awesome. Thank you so much, Jake. I mean, you started off the presentation very, very strong by mentioning supply chain. I feel like that is currently just everywhere that I look. Everyone is always talking about like supply chain issues and the security issues involved there. So yeah, I mean, fantastic presentation and demo. We've actually we've got some questions here actually. So the first one comes from John in Slack. If you do have, by the way, anyone watching, if you do have any questions, feel free to jump into the Slack channel and ask them as well. So John says, great session, Jake. Appreciate that GPG signing commits is another layer of defense, especially if the user didn't have two-factor authentication switched on. However, I've been challenged before when recommending signing commits. How much does it really reduce the risk, especially if a user is using two-factor authentication versus the effort to set it up and ensure users maintain keys?
Yeah, it's a really great question, right? And it comes back to what I touched on at the end around, getting that balance between usability, but also control. Once you've got a slick setup in terms of being able to set GPG up, a couple of years ago when we tried to do this in one of our accounts, one of our projects, it was actually really difficult to get GPG working correctly because it was tricky. The tooling wasn't quite there yet. GitHub was still in the early days of supporting this, verified GitHub related GPG signed code. And lots of different tools didn't quite support it yet. So we're using things like Tower or Source Tree, and it wasn't quite there, and it was all a bit janky, and you had to run a lot of different things in order to get it to work. Today, though, you run like 2-3 commands, you verify your commits, you push, and it's done. So the amount of effort, I think, is actually a lot lower than it used to be, and I think that might be a hangover from a couple of years ago when it was bad. It was bad, and today I think it's a lot easier. So I'd probably go and have another look, see if it is still as hard as you remember it being. And if it is still as hard as you remember it being, then it's putting together some really clean docs for your engineers and your team to be able to really ride that out in terms of, look, there's a one-time pain hit up cost, but we get benefit for years, right? In terms of every single commit is verified all the way back to, when we start doing this. And then we can then see that we know that you, Jake, actually pushed this, or you, John, pushed this code into this repo at this time. We know it was definitely you because it's private keys and definitely most likely to the 99th percentile. But it really comes down to the appetite. If you've got other problems and other fires, I would address those fires first. GPG is probably one of the latter ones on the list that I would be looking at if you've got no branch protection or you've got admin access everywhere. I'd be looking at those things. But thanks for the question.
Cool. So we've got another one, which, so you've spoken a lot about GitHub and a lot of the sort of security prevention risk measures that you can take there. But is everything that you're talking about actually applicable also to other code hosting platforms like Bamboo or GitLab?
Hopefully, yes. This example was very heavily focused on GitHub, is given it's the most popular tool at the moment, but all of the things I've just talked about will all have representative examples or controls within their given environment. So, in GitLab, for example, I know that they have pretty much all the same things I just talked about. They might be called slightly different things, but it's about just, again, the idea of get in there, dig through your different settings, have a look at what you've got set up at the moment, and see where you need to make those changes and make those recommendations to your organization. Say, hey, look, I actually think we should probably tighten this up here or loosen this up here and make these changes. But fundamentally, I think that all of the same things, all of the same principles in terms of the key elements all apply to across the board, any different tool you're using for code hosting.
That's really good to hear, because obviously, GitHub is massively used, as you demonstrated in your presentation, but it's not the only thing there. Cool. So also, if you have a crystal ball of any sorts, Jake, what do you think are sort of the next risks to think about after everything that you've already spoken about so far?
Yeah, so obviously we talked about vulnerabilities up the front, so making sure that our code that we put in terms of open source isn't vulnerable. We're making sure that we've sort of got our secure enclave for our code that we're hosting ourselves, that we've written, the proprietary code. So it's then starting to look at the bit I talked around the supply chain at the very start around that next part is how do we make sure that the artifacts we're creating and then deploying into our systems aren't vulnerable and aren't that we know that they are what we thought they were. Because when we built it and we pushed it to that place, how do we then make sure that the deployment tool or the system running it knows that it's the same thing? And that can be the next challenging part. That's actually quite difficult. There are tools around solving that. Can't think of any off the top of my head at the moment, but that is the next piece. So it's always looking at your supply chain end to end and thinking about how do you then secure the whole thing from the top to bottom. So I would probably then try and tackle that if you've got secrets management under control.
Awesome. Just going to quickly check if we've got any other questions. No, I think we're good. So thank you so much, Jake. That's all the time we have for today. But obviously, anyone watching this, please do continue to drop questions into the Slack channel, and we'll try and get those answered for you. We know that a lot of you, watch these videos afterwards, and Jake is living in that Slack channel now as well. So feel free to tag him and pester him if you've got any other questions or hints and tips that you would like to ask him. But yeah, again, huge thanks, Jake. It was great to have you on the virtual session today, and it would be great to have you speak at other things too, because GitHub and also source code management systems are only going to get messier, and we're going to only have more and more to worry about. So it'd be great to get a refresher at some point soon too.
Sounds amazing. Thank you very much.
Thank you for coming, Jake. Really, really appreciate it. So our next session is actually for DevSecCon London is actually going to be in next year, the start of next year. But the next session for DevSecCon Global is actually going to be in 2 days on November 25th, and will be DevOps Strategy for Developers with Timo Pagel. You can actually register for the event now on the DevSecCon website if you hit global events. But in the meantime, I hope you enjoyed the session, and please remember to share the video and tell everyone else in the community. Thank you again, Jake. You've been an absolute gem. And we have been DevSecCon, an inclusive community that educates and enables developers in application security. Thanks, folks.